Camera le pongo. Yeah.
Everyone, mostly this is colors and the audience, which is not necessarily to have any sort of discipline. This is an activity or event which is of highest academically. As you all know, our university is better known for discipline or academic discipline. I also don't want to speak frequently at period of time. We are not normal students. We are supposed to be. So it is time to welcome the welcome address. I cordially invite Professor Satish Kumar Nanda, Vice Chancellor, to deliver the welcome address on the occasion of celebration of National Technology 2025, organized by the city today.
Estimable কিছু পারিব না দেখো হ্যাঁ ইউএস প্লেনে ইউএস প্লেনে করব না
But also very
শেষ পর্যন্ত চললাম গাড়িতে নেবো তাদের
and all these
এটা মোটু নব ଯାଉନି ବୋଲି ଆଜିରେ ମୁଁ ନୂଆଟା ପୁରା ଯଦି ସେଇଟା ତାକୁ ଦେଇଦେବି ସେ ସ୍କ୍ରିନରେ ପଡୁଛି ଜଏନ୍ଟା ମୁଁ
right from the other device to this test. I look at the sector, I think it was not visible like 60 years back, 70 years back, but it's quite visible now. My time is now, and everybody plays with the AI, which is the data, is us. And we're creating very different dimensions of the technology. So look at the any sector, education sector, health sector, the transportation sector, communication sector, energy sector, and whatever, all the sectors, transportation, technology has created a role. And even the defense also recently we have seen the kind of the technology impact on agriculture. So that's what technology is. If you go back to the entire world, it has reshaped the world and reshaped the also civilized. And if you look at the many people who have contributed, and India has produced a lot of many technical scientists who are really contributing. And also now India is becoming Atmanirbhar, which is evident from recent kind of the companies that which helps us. So I think different fields of the discussing. And there are going to be different and the next sentence will be there. This is the future where technology is driving us, not IT. And that has been given a slogan by our that everywhere people should be there and it should be to the last mile of the society. So therefore you can see that even the kind of the person at the last mile of the society is using technology for agriculture, for health, for whatever. And they have device. So therefore technology has been pervasive in ubiquitous industries. So therefore, as a university also it has become, I think we are working with the university and technology also and application of technology in all the sectors, to be our health sector, agriculture, we have material science, all the sectors are in technology and information. And therefore, if you look at this contributors who are contributed, I salute the people who have pursued their career in technology and who are contributed whatever way to the technological field, which particularly of the mind. And we all feel that in our subject and India has also grown over the years for significantly and marvelous technology and science for support in this kind of programs. And also in Chandrayaan 3, we have seen the marvelous technology which I think India one appreciates our technologies, our scientists from school. So therefore, I believe that this kind of event will remind us and also encourage the contributors, the researchers, the students, the faculty, and across the online and across the field to innovate and to contribute for the development of mankind. With this, I must be and with this, I thank everybody, and especially Dr. Kadi, who has traveled all the way from Mumbai and to deliver these technology reactors. Thank you very much. God bless you.
Thank you, Honorable Vice Chancellor, for having given some address to the recent incident in connection with the war between India and Pakistan, particularly the BrahMos, the indigenous technology. And now I request what I can say, the co-host representation must be there. So I request Professor Subramanian and Samdroy on behalf of INE and INE Rotation Chapter to elaborately tell about the INE role in this national technology day celebration.
Very good afternoon to all of you. Professor Tyagi, today's keynote speaker from the Indian Community, Professor Ram Acharya, the chairman of the committee of this university, as well as the chair of INA Research Chapter. Professor Member, Vice Chancellor of this university, Professor Korila, Professor Viken Misra, the ex-director of IIT Goa and IIT, and right now the distinguished visiting professor at IIT. Professor Ganapati Panna, the ex-deputy director of IIT Goa, the faculty members,
students or scientists may be here, media persons, so ladies and gentlemen. So we are right now landing to an occasion where we are going to celebrate the Heritage Day. Before that, I will throw some lights on Indian National Academy of Engineering. You know, established in 1987, 38 years back. This Academy of Engineering has distinguished engineers, scientists, and technologists covering the entire spectrum of engineering in this country, as well as abroad. So the IIT focuses on is one of the apex body of engineering in this country. It focuses and promotes the practices of engineering and technology related to sciences and their application in solving problems of national importance. This academy provides a forum for future planning for countries' development requiring engineering and technological inputs, bringing together specialists from all the fields that may be necessary for the comprehensive solutions to the needs of this country. The activities under INA banner includes programs on issues of technology policy and recommendations for various domains of engineering and applications in different fields. And it promotes research, projects, pilots, engineering education, fellowships, scholarships, awards, and different forms of recognitions to draw attention to bring the real intellects to different forums of and if you look at IIA fellows are very distinguished persons in this country, and they have a provision of making today there are 1,000 IIA fellows in this country in different engineering and science together, and 100 foreign fellows. And IIT has made a bracket. The fellow numbers should not go beyond 1,200 at any time for the time being. So we have 1,100 fellows, including India and Europe, and they are working in different fields and bringing solutions to different emerging problems of engineering applications. Together. So this has been a recent move from IIT. So IIT has the apex body in this country working since 38 years, and reasonably things are happening in different spectrums across the different disciplines. Now to further create one platform for new knowledge dissemination in local cities and states, IIT decided to create IIT local chapters. And right now we have around 10 local chapters, including IIT Bhubaneswar chapter. Now IIT Bhubaneswar chapter started in 2021. It's almost 4 years plus. So we are entering into the 5th year. And it's creating many activities. There are almost more than 40 IIT fellows that belong to the state. That means we have people who are in this origin and they are also fellows working outside. So total number may be more than 40 right now. And IIT Bhubaneswar chapter is really bringing new knowledge disseminations, bringing many people of different expertise, and has collaborations with SO University, IIT Bhubaneswar, NITER Bhubaneswar, IMMT Bhubaneswar, then ICT IMC Bhubaneswar, and IEEE Bhubaneswar section. So all are coming together and they are bringing the programs under IIT plan. So IIT Bhubaneswar chapter is really engaged in new knowledge dissemination, including the keynotes, and also we are planning to schedule programs which can address emerging issues in the state that we are studying. I Bhubaneswar chapter organized on a milestone event of INA annual convention in 2023 in this place. And it was one of the remarkable INA convention in INA history, which has been appreciated by the INA people. So I very thankful all for being part of this technology-based celebrations. I will not much speak on technology because the speaker will speak more about all this. So thank you very much for your presence and becoming part of the technology 2025. I will not take. Thanks.
अक्टोबर होईल तो ते बोलता ऑरेंज कलर के बोलता अक्टोबर बघितलं तो
I'm calling someone who is considered to be the most revered, experienced, and very senior professor, and he is one of the Odia who are occupied the highest position in the apex body of technical education, Professor Ramachandra. For 2 minutes, sir, I request I was really hesitant not to speak, but I convinced her at least speak for 2 minutes, particularly on the national performance day. Professor Ramachandra said, let's have a big round of applause.
Our favorite teachers today, Dr. A.K. Tyagi, our honorable Vice Chancellor, Professor Nanda, distinguished fellow Academy of Bhubaneswar Chapter, and other sister institutes, I find also from institutes where children are
डिस्टेंस
our faculty, students, and IIT fellow young associates who are studying senior honors in this very first lecture of the National Technology Day. And we are really proud that IIT headquarters reports the result saying that your chapter is one of the most active chapters of IIT, and we must be able to in a repeating manner. And I am very happy to say that all our collaborating institutes, they have also come forward to hold this National Technology Day lectures in 4 institutes on 4 different days. Today is the first day. Next one will be in IIT. Sorry, next one will be in IIT Bhubaneswar. Third one actually will be in IIT Bhubaneswar. And fourth one will be in IIT Bhubaneswar. And it will be addressed by some of the top technologists of this country. That research is a very big thing. And so far as this IIT Bhubaneswar chapter is concerned, so far we have been able to organize or hold 3 distinguished lectures, all in virtual mode and with speakers, not only from India, many of them are also from abroad. And they have been really helping us to hold this thing. We have also held here very successfully INA National Convention in this auditorium itself a few years back. And with this thing, INA Bhubaneswar chapter is really doing very well. And it is to premature to say, but I may say here, we have also requested to hold National Convention of Bharati in 2027 here in Bhubaneswar. And maybe we will agree, we will have another grand event here. So, thank you very much. Let us actually let me not waste much of your time, and we can now go ahead with our program. So the next one will be the introduction of the GPS by Professor Pulamani, who is actually his friend and colleague in the same research field. So he is the best person actually to introduce. Thank you.
Professor P.K. Lunda, Honorable Chancellor of this university, Professor A. Tyagi, with the main attraction concern and train and will research to our university. Professor P.K. Mishra, my director, IMT, ex-director and director of Professor Gulati, Professor Yushi, and Professor Siddham. And the faculties of this institutes of
Tyagi, I have been entrusted the responsibility by this university and INE to speak few things about his achievements and his success. And his biodata very vast. You can write history, and also it is very vast. For some of the important points, I wanted to tell before you, because you should know something, his great personality, something about him before he starts the talk. Professor Dr. Abhesh Kumar Tyagi, popularly known as Professor A.K. Tyagi, joined chemistry division of BRC, that is Bhabha Atomic Research Center, in 1986 through BARC training school program. Every year they recruit most talented students to pursue research under training school program under BRC. Then subsequently, he received PhD in 1992. He did postdoctoral research at Max Planck Institute, Stuttgart, Germany during 95 and 96. During the spanning career of 4 decades, At the early age, maybe around 20, he joined at a BRC tennis school. During 4 decades of his stay at BRC, he occupied various positions. I was just amazed to know he was heads of 5 groups, such as chemistry division, head of analytical chemistry divisions, head of radiation medicine center, then director of chemistry group and director of bioscience group. As a person, and each inevitably so much importance has been given in BRC system. He was distinguished scientist of a DAE at present. He is holding Dean and Senior Professor of HBNI, that is Homi Bhabha National Institute, Mumbai. And beside that, he is an honorary professor of one of the most prestigious institute, that is called JNCASR, that is Bangalore. He is an honorary professor there. And his research interest matches very well to the priority areas of our university, that is in the field of materials, process and technology, of nuclear sectors, nanomaterials, functional materials, and hybrid materials, most of them material sciences. And he has guided around 50 students for PhD and written 15 books and published 600 papers in peer-reviewed journals. Just it is one of motivating. Why I am telling this thing repeatedly, it will motivate the younger generation, the students, research scholars. That's why I'm narrating his biodata. That about his professional career. Then let me tell something about some few awards what he has received. He has been conferred with DAE Homi Bhabha Science Technology Award, DAE SRC Outstanding Researcher Award, DAE Group Achievement Awards 4 times, DAE Group Achievement Awards 4 times, 4 MRSI Awards. MRSI means Materials Research Society of India. 4 awards. That's MRSI Medal, MRSI ISSC Material Sciences Seniors Award, MRSI CNR Prize in Advanced Materials, MRSI Distinguished Material Scientist of the Year. The 4 awards from Material Research Society, the premier Society of Material Science in India. Not that one. 3, that is CRSI Award. CRSI means Chemical Research Society of India. That is CRSI Bronze Medal, CNR National Prize in Chemical Sciences, CRSI Silver Medal. Then some few I will tell you. Rajiv Goyal Prize in Chemical Sciences, Metallurgist of the Year Award from Ministry of Steel, Government of India, National Prize in Solid State and Materials Chemistry from JNCASR. Indian Chemical Society confirmed him Acharya PC Rai Memorial Award. Then from Thermal Analytical Society gives NIS ITAS Award and DN Agarwal Memorial Award. For Indian Ceramic Societies, gold medal from Chirantan Rasayan Sanstha and ISAS Shastra Tejas Award, among all awards. And you will see in 2024, he has been conferred with the Vigyan Shri Award by the President of India. And that Vigyan Shri Award is equivalent to Padma Shri. And this is a person getting so many recognitions, so many awards. It is sitting among us just now to giving a Technology Day award. Then let me tell something about his academic fellowships. He has total 9 national and international science engineering academic fellowships such as National Academy of Science, India, FNSC, Professor Acharya was telling 26 or 27, will hold it here. This annual convention, Indian Academy of Science, the FSCC, the head office is Bangalore, Indian National Academy of Engineering, FNA, Indian National Science Academy, the FNA, and Royal Society of Chemistry, FRSC, Asia Pacific Academy of Materials, World Academy of Ceramics, African Academy of Sciences, and the World Academy of Sciences. 10 fellowships from 10, not India, but international 5, he has been received. After telling his scientific career, his recognitions, his fellowships, something I'll tell the personal accomplishment, personal things about him. He has just, I would put it like that, he has been encoded with numerous extraordinary human values, as well as exemplary citizens. Response is sensitive matter positively. If you send a mail to him, he will immediately give reply very positively. And whosoever approaches him, he encourages them. And some of his very old students, they are here to hear. Because of his bonding with the guide and the scholars, they are present here. He is very well known for every academic institution of Odisha. He is very familiar. He has unique affections and connectivity to Odisha. As a close friend, I got to know this quality with him. And he has traveled across Odisha, many institutes, from east to west, north to south. Many academic institutions to know him. He is such a figure, and when Professor Acharya invited him, he has agreed instantaneously, and he has always loved to come to this university. This is third visit. Thank you. I have covered some of his CV. Thank you very much.
Thanks, Professor Parida, for very generous introduction of mine. Most respected Professor Damodar Acharya, sir, Professor P.K. Nanda, Honorable Vice Chancellor of SOA University, Professor Samantare, who represents INAE and IIT Bhubaneswar. I see some of the most respected people sitting in the front row and other rows, Professor Panda, Professor B.K. Mishra, Professor Mohanty. I have known many of them for last several years. And last but not the least, the young students. I must first greet all of you while saying Jai Jagannath. I have been coming to Odisha. Since 1991. 91 was my first visit, and I visited that time. IIMT was called RRL Bhubaneswar. There was a ITAS conference organized by Professor S.B. Kanungo. I recall very well. I was in my 20s. My first visit to Odisha, I went to Konark and Puri and Pimpli. I remember as it all this happened just a week ago, and I had large number of students from Odisha. I had large number of students from, of course, other parts of the country also. I always say, young students, be global be local. While having local roots, have global thinking. That's why you become this kind of person that you connect with each and every one. And as I mentioned, of course, don't leave your roots from your home state. Extremely important. I must admit that it's a huge honor for me and a pleasure to deliver this lecture on the momentous occasion of National Technology Day, being organized jointly by SOA University and INAE Bhubaneswar. INAE also is, I'm pretty close to INAE. So when this invitation came, I very promptly agreed. And here I would like to thank Professor Ajit Kumar Mohanty also, our chairman of Atomic Energy Commission. He also called me around that time that such invitation is going to come, and how I am placed around this time. I told, irrespective of that fact that how I am placed there, I am going to accept this invitation. That's my commitment to all of you. And you see today me in front of all of you. So today I'm going to discuss on a very important topic, sustainable development, and how nuclear science and technology is going to play a key role in this. This is the main focus of my talk. As Professor Parida mentioned, that after spending close to 4 decades at BARC, last year I moved to HBNI, my new place of work. It is in same campus. Many of other colleagues, I can see Sriparna, Rojaline, they all have seen both BARC as well as HBNI. HBNI is presently sixth ranked university in India as per NIRF ranking among research institutions, and 16th rank among university category, 27th rank overall. So these are kind of credit HBNI has got, and that of course is because of the great organizations which are affiliated to us in terms of academic programs like BARC, IGCAR, RRCAT, VECC. Bhubaneswar, we have got two institutions, NICER and IOP. They are also, part of HBNI in terms of academic programs. I move forward. Whole world is talking about sustainability. Sustainability can be described in 2 words, just 2 words. And what are these words? Intergenerational equity. What does it mean? Our generation, me and you all sitting here, have no right to use the resources meant for future generations. Number one. Number two, our generation has no right to leave behind waste, thinking that future generation is going to take care of that. With this philosophy, sustainability goals have been defined by UN. I will discuss. It is important that we go for economic development, social development, but not at the cost of environmental development. That's extremely important. We have to respect environment. I read a lot of books here, not only physics, chemistry, and engineering. I read a lot of journal books also. Presently, I am reading a book, Why Civilizations Fail. One of the reasons is that ancient civilizations or medieval civilizations did not take enough care of the environment, and these civilizations failed. Topic of separate talk, sometime we'll discuss these things also. So I move forward. We discuss always what happened post-industrialization about 2 centuries ago. We all know human activities increased. We did this, we did that. Even in last 7 decades, our human activities increased considerably. You can see CO2 level has gone up from about 320 ppm. It's okay, I'll manage without this. So from 320 ppm to today it is 430 ppm. And we all have been reading that if it touches 450 ppm, it is going to be alarming. And 450 ppm level of CO2 is knocking our door. You can see from this adjoining table where I am showing increased rate of CO2 ppm per year. In 60s and 70s, it was about 1 ppm per year. And you see in last decade, it became 2.43 ppm per year. Last 5 years, 2.67 ppm per year. With this growth rate, 450 ppm is going to, this number is going to be reached in another 5 to 8 years, 10 years maximum. And then, many things can happen. Already we are witnessing so many catastrophic events in our day-to-day life. And all this is because of how we handled our environment in last 200 years or so. Sorry for some technical glitch. It moves. So what are the activities, human activities, which are generating CO2? Some of the discoveries of last century, which we all have been championing, became big villains. Discovery of ammonia in 1913 by Haber process got so far 3 Nobel Prizes. It got Nobel Prize for discovery itself, Nobel Prize by Bosch in, I think, 1919 for scaling up, and 1 Nobel Prize came in 2007 or 8 to Ertel for proposing mechanism of discovery of synthesis of ammonia. Such is the impact of ammonia. If ammonia was not there, I don't think Mother Earth could have, sustained 8 billion people as on today. Ammonia is used to make fertilizers. Ammonia is used to make so many drugs, pharmaceuticals, which we pop up in the morning, people of my generation especially, all have nitrogen, and that nitrogen comes from ammonia. Fourth Nobel Prize also is going to come. Young students, please listen carefully. You should grab this Nobel Prize for our country. If you can develop a green process to synthesize ammonia at large scale, industrial scale, be assured India and Odisha is going to get Nobel Prize. So these are the areas which we should work on, young students and other faculty members sitting here. Cement, steel, aluminum, plastic. We can't imagine our life without this. All of them are contributing 31% of carbon dioxide. Electricity has become part of our life. And this also is a major contributor. Growing things, food, plant, animals, all this contributes to the extent of 16%. Getting around, we all travel by train, by plane, our personal cars and so on. That also contributes. Okay, thank you very much. That also contributes to 16%, and heating, air conditioning, refrigeration, 7%. So these are the various contributions, broadly speaking, of generation of carbon dioxide and other greenhouse gases. Now, how different heavy industries generate carbon dioxide? Power is maximum. Power, it means everything. Electricity, heating, cooling, transport, everything is clubbed together as power. Then we have got steel, more than 3 billion tons of CO2 per year. Ammonia, already have discussed at length. Cement, plastic, clothing industry also is no less polluting. So these are the heavily polluting industries. That's why, it is very important that we should also learn to become responsible consumer. That is also supposed to be developed technologies. Green ammonia is one, green hydrogen, green steel, green cement, green aluminum. Can we get aluminum from bauxite? This part of the country, Odisha, is very rich in bauxite. Damanjodi, such a big plant is there of Nelco. So can we develop a process as a chemist where we get aluminum from bauxite without using, carbon producing chemicals? These are the very hot topics of research for your generation and for that matter for our generation also. In order to contain the damage done in last 200 years, knowingly or unknowingly, mostly unknowingly only, nobody does bad things knowingly, I personally believe. UN convened a convention wherein after a lot of brainstorming, 17 sustainable development goals were formulated. They are no poverty, zero hunger, quality education, industry innovation, good health being, gender equality and so on, clean water, sanitation, reduce inequalities, sustainable cities, peace, justice and strong institution and so on, climate action, life below water, life on land. All these 17 goals can keep all of you very busy for your PhDs and post-PhD career. This is the future which is waiting for you. You will be surprised to know out of 17 development goals set by UN, in 8 goals, nuclear science and engineering can directly contribute. And 2-3 more goals are there, we can contribute indirectly. What are these goals? Economic growth, zero hunger, good health, clean water, quality education. We have got world-class institutions with us and they generate highly talented people. Tata Memorial Center, which is in headquarters is in Mumbai, and Bhubaneswar also in nicer campus, one center is going to come up. Likewise, there are 10 more centers, 12 more centers. So 40% oncologists in India have some or the other linkages with TMC. This is the kind of impact DA is making in this very important area in the field of health. Life on land already have discussed. So these 8 goals we can make direct contribution and we can make indirect contributions in other 3 or 4 goals. About 10 to 11 goals, nuclear science and technology is capable of contributing. You all know, of course, for the benefit of young students, Honorable Prime Minister went to Glasgow, UK in 2021 and he committed net zero target. All of you must be hearing net zero. Net zero does not mean that we stop to produce carbon dioxide. It means if we produce X million tons of CO2 in a given year, X million tons of CO2, we somehow remediate. So net is zero. X is produced, X is fixed. And nature has been doing carbon fixing for centuries. Why centuries? For millions of years. Nature produces X tons and fixes X ton. Complete circle. It is only human activities which have, changed the balance completely. So that's a net zero target. And what is the commitment? India will increase its non-fossil energy capacity by 500 gigawatt by 2030, meet 50% of energy requirement from renewable energy by 2030, reducing 1 billion of tons, actually 1 billion tons of greenhouse gases emission by 2030, reduce carbon intensity by 45% by 2030, and we are going in that direction as nation. Target of net zero by 2070. This target is huge. We all have to contribute. Each and every individual has to contribute, and one can do at least by producing less CO2 in your day-to-day life. This is one thing I am telling everyone. Ensure that you become champion of this cause for the sake of generations who are going to follow us. Now comes role of nuclear. This bar diagram tells you the amount of carbon dioxide in grams per kilowatt hour. In simple language, per unit. Kilowatt hour is 1 unit, which we all are used to in day-to-day life. Here is coal, 820 gram per unit. 740 is for biomass, natural gas, and so on. Here is nuclear. Only 12 gram carbon dioxide per unit per kilowatt hour of carbon dioxide footprint is of nuclear power plants. And now the kind of renaissance nuclear is going to see. Already you see the support, tremendous support from Government of India, from policymaker, from finance. Everyone is talking about nuclear these days. So nuclear definitely is going to get remarkable awakening in all over India, all over world, and in India definitely. So wind is of course also equal, but there's a major difference. You will be surprised to see how nuclear, despite the fact having same carbon footprint, can extremely highly compete with wind. You will see from next slide. Here is a relative comparison of land footprint. CO2 footprint is 1, then comes land footprint, then comes human resource footprint. There are many things which one has to talk in totality. One cannot talk only in isolation. Everything has to be seen in totality. So this is the land requirement, relative scale, biomass, hydro, wind, solar, coal, natural, and this is small. It is like a bindi which our mothers and sisters wear on. This is the relative size of nuclear power plant of same capacity compared to other plants based on these technologies. That's where nuclear scores over. Nuclear gives very high density of electricity, and that's very important to maintain the balance in the grid. Many things are there which I can talk, but I should change slightly. And now I should tell the story of a great son of India, Dr. Homi Jahangir Bhabha. So my talk will have 3 or 4 segments. One segment was sustainable and its definition, its goals, and all that. Second segment of my talk is my talks are full of stories. That is true for my scientific talks also. In scientific talks also I tell a lot of stories. Mostly they are of course scientific stories of Nobel Prizes, stories of people missing Nobel Prize, and so many things are there. All those things we will not discuss. Dr. Bhabha in 1935, 90 years back, was pursuing a great career in physics in Cavendish Lab, UK. Dr. Bhabha could have got Nobel Prize. He was this kind of genius. And Dr. Bhabha's friend circle who used to take coffee with him were Rutherford, Dirac, Anderson, and so on. Niels Bohr was his close friend. Dr. Bhabha was happily pursuing great physics. Everything was going on well. In 1939, in the month of August, Dr. Bhabha came to India to spend a couple of weeks with his parents in Bombay. It was Bombay those days. So destiny had different plan for that. Happens, by the way, to individuals also, to people like us also it happens. Destiny had a different plan for Dr. Bhabha, different plan for the nation, and different plans for maybe all of us. On 1st September 1939, World War II started. And Dr. Bhabha in this process could not go back to UK. So one life lesson to young students, sometimes things may happen which you don't expect at all. So convert difficulties into opportunities, as simple as that. And Dr. Bhabha did that. Dr. Bhabha joined IISc Bangalore as a professor. This is great institute that time was headed by Sir C.V. Raman, Nobel laureate of 1930. You all know about this. We celebrate Natural Science Day on 28th of February of every year. But Dr. Bhabha was not the person to remain happy as a professor for his whole life. Dr. Bhabha wanted to build institutions. So with the help of Sir Dorabji Tata Trust, Dr. Bhabha decided to build TIFR, Tata Institute of Fundamental Research. So initially for a few months, on June 1st, 1945, Dr. Bhabha initiated TIFR from IISc Bangalore campus, Cosmic Ray Research Lab, IISc Bangalore. I go to also reasonably often. By December 1945, this institute moved to Kenilworth building. You see all these photographs. Subsequently to OIC. OIC is this building. This is the headquarters of Department of Atomic Energy. Dr. Ajit Kumar Mohanty sits here as Secretary of DAE. This is just in front of Gateway of India, the iconic building if you come. Subsequently, TIFR moved to Colaba, the present campus. I am sure many of the people must have been to Colaba. So this is a story of Dr. Bhabha, and Dr. Bhabha also, he was not happy to just with this TIFR. Dr. Bhabha convinced then Government of India, then Prime Minister of India to initiate Department of Atomic Energy. In 1948, after persuasion of Dr. Bhabha, on 10th of April 1948, by Act of Parliament, by a presidential order, Atomic Energy Commission was set up with Dr. Bhabha as chairman, Dr. K.S. Krishnan and Dr. Shanti Swarup Bhatnagar as two of the members. So from a small level, we started Atomic Energy program. And on 3rd January 1954, Atomic Energy Establishment Trombay was set up. People must be thinking, what is this AET? Present day BARC. On 24th of January 1966, Dr. Bhabha died in a plane crash while going to IAEA, and very next year, then Prime Minister of India renamed BARC, renamed AET as BARC, as I show. Some of the historical photographs, as you can see, is shown here. Science history is very important. I'm telling everyone, doing good science is one thing, but you also must know good science history. That brings you too close to the roots. How great people have done great science, what they had, which many of us may not have. They are the motivating stories which are very important. So Dr. Bhabha could think of atomic energy program in this country in 1948. When country was not making even bicycles, he thought of making nuclear reactors. Such was the vision. And you see limited finances, limited scientific and technological manpower. Our literacy rate in 1947 was 12%. Now we are 76%. We will be 85% in coming years. So you see the difference now. An inadequate industrial base, extremely small reserve of fissile element and so on. How he could think of all these big things, big department, because of his sheer determination and by his love for the nation. I will show some slides as I proceed further. Let me move forward. So from humble beginnings to present day DAE. Present day DAE is the largest science and technology organization in this country. We have got about 30 plus units all over India in 110 locations, as you can see. We have got R&D sector, BARC Trombay, IG Kalpakam, RRCAT Indore, VCC Kolkata, AMDR Hyderabad, GCNEP Bahadurgarh. We have got industrial and mineral sector. Nuclear fuel complex Hyderabad is the largest integrated nuclear fuel facility in the world. Heavy Water Board is the largest producer of heavy water in the world. You know the largest heavy water plant, where it is, young students? It is right in your home state, Telcher. Telcher has got the largest heavy water plant in the world, leave alone country. BRIT is of course our commercial wing. Uranium Corporation of India Limited, Electronic Corporation Limited, Hyderabad, IRL is for rare earths. And here in Odisha, we have got 4 units of DAE. As you know from this, we have got aided institutions. We have got TIFR, SINP, TMC, HRI. Here is HBNI. And power sector is looked after by NPCI and Bhavini. So this is a brief introduction of DAE. It's a matter of separate talk. Sometime we'll discuss when I come next time. Some of the milestones in this journey, just to motivate younger students. Apsara reactor was commissioned in 1956, the first reactor in Asia. So Japanese did not have reactor at that time. Those days Dr. Bhabha could build with the collaboration of UK, a nuclear reactor in India. And this one is 1960 Cyrus reactor, and this is 1985 Dhruva reactor. I have very fond memory of Dhruva reactor. 1985 is the year in which I did MSc and I joined training school of BRC as Professor Parida introduced. I remember vividly, extremely well. It was 11th of November 1985, Monday, when then Prime Minister Rajiv Gandhi came to dedicate the reactor to the nation. At this event, I witnessed as a young boy of 20 plus, standing somewhere here. So these are the memories which you never forget, and you must use these events to motivate yourself to do better and better. After traveling all over world, more than 30 countries, one thing I can tell you: the kind of science opportunities you have in India, no need to go anywhere. The massive career is waiting for you right in India, right in your home state. So this is a message to younger students. I move forward. What's the mandate of DAE? DAE's mandate is power program, healthcare, medical sciences, food security, water security, industrial applications, and research. Now, in third leg of my talk, I give some examples and where we are contributing and where we can contribute more for sustainable development goals. So first few slides in third leg and perhaps the last leg of my talk is energy sector. So India has got very small reserve of uranium and very vast reserve of thorium. So in view of that, Dr. Bhabha decided to go for a 3-stage program, as you see in this slide. Stage 1 is having pressurized heavy water reactor, PSWRs. Stage 1 is fully into commercial domain. We are right now 20 plus reactors. Stage 2 is having plutonium-based power reactors. PFBR Kalpakam prototype fast breeder reactor is now going to become critical, hopefully by end of this year itself. And this is stage 2. Stage 3 is going to be uranium-233 based reactors, and this is mainly at R&Ds. So this is the, in nutshell, introduction to 3-stage power program of our country. Nowadays, we hear a term which is called as circular economy. Everything is circular. Nothing is waste. You will be surprised to know what whole world is telling today about circularity of the economy. Dr. Bhabha started to practice 7 decades ago. So Dr. Bhabha adopted a closed nuclear fuel cycle, circular economy only, from uranium mines and mills to oxide to fuel to reactor. Then we get spent fuel to reprocess, and we separate lot of radioisotopes for medicine, agriculture, and industry applications. Uranium is recovered, fed back. PU is recovered, fed back, and a small volume of waste is remaining for immobilization. So this closed nuclear fuel cycle is the hallmark of Dr. Bhabha's vision, which we continue to follow now also, and I think from this we will not deviate. Now very quickly to share the kind of reactors we have as of now. Presently we have 25 reactors, all put together contribute to about 9,000 megawatt power, but they produce lot more electricity compared to equivalent solar, for example. We can discuss these things. By another 5-6 years, this is going to increase to 22,480 megawatt in another 6 years. So major jump. So let us see how we started. In 1969, we had first power plant. So this phase I call as years of struggle. This phase I call as phase of consolidation. And last 10 years or 12 years, we have got phase of rapid expansion, as you can see. Honorable Prime Minister Shri Modi came to Kakrapara reactors and dedicated 2 power plants, each 700 megawatt, to the nation on 23rd of February 2024. So this is the power sector, the stage 1. Now, I told you that we are going to touch to 22,480 megawatt. You may ask a question, how we are going to do? So presently, 8 reactors are under advanced stage of construction. 10 reactors we have got sanctioned. In addition, we are having reactors under construction. They are imported, VVER, EPR is going to come. All put together, we are going to get considerable increase in nuclear power production. Why it is so important? Why I told you that for net zero, nuclear is going to play an important role? Because CO2 footprint, you recall my slide, 12 gram per unit. So already in India, by nuclear power, we have saved 70 gigatons of carbon dioxide. And when we go for rapid action, you can see how much carbon dioxide we are going to save and contribute to the commitment of Government of India, net zero by 2070. So this is the first set of examples in nuclear energy. Now, very quickly, I will show a few slides on food security. Here, how we do what we do. Radiation, we think of 2 things. Nuclear, we think of power applications. But nuclear has lot of non-power applications also. Now, my other examples are in this field. As you know, India is a tropical country, and that's why food spoilage is very common. Lot of food is spoiled. You will see on roadside, this everywhere. So we have developed radiation-based protocols for shelf life extension of onion, potato, this is litti, these are of course prawn, mango, and so on, and spices. Now after controlled radiation, these food have shelf life of 1 year plus, and so on. So these are contribution towards food security. This work started in BRC in 1967, and presently we have got about 32 food irradiators in this country. So America was not buying mangoes from India for right reasons, because they thought our mangoes may have some pathogens. Each mango has some local pathogen. So by radiation-based technologies, we have developed a protocol wherein every concern of US has been taken care. And now from 157 metric tons in 2007, 2023 we could export 2,500 metric tons of mangoes. So a trade barrier which existed between India and US could be broken by nuclear technologies, by non-power applications of nuclear technologies. This is one example. And we are also developing Trombe crop varieties. Trombe crop varieties are the developed varieties of seeds, rice, wheat, etc., which have got much higher productivity in terms of quintals per hectare. Total 70 food crop varieties are there. Groundnut 17, mung bean, mustard, rice, and so on. And you can see the advantage. The yield is very high. This is the Chhattisgarh Trombe Java food. So rice variety, its yield is 40.3 quintal per hectare compared to original variety can give 28.7. This work also is being appreciated by everyone, and we are going to multiply these 70 Trombe crop varieties are going to become many more in numbers in coming years. So these Trombe crop varieties have been deployed all over India, including Odisha. Odisha is known for groundnut, mung bean, and jute and black gram. All these varieties developed at BRC are in use by our dear farmers from Odisha. But I must admit that we should not stop here. Lot more has to be done. Trombe crop varieties have to penetrate much more deeper, and I promise you here on behalf of Department of Atomic Energy that no stone will be left unturned unless all the farmers get benefit from this kind of, as many farmers as possible get benefit from this kind of developed Trombe crop varieties. Now I come to health sector. Bhubaneswar is a hub of so many medical colleges, so many medical institutes. I really compliment Bhubaneswar has become a center of higher education, and all these happened in last 30-35 years. I have myself seen when I came to Bhubaneswar in 1991. Since then, what not is available in this part of the country, Bhubaneswar. And that's why, I like to come to Bhubaneswar as and when I get invitation, I try to accept here. So what is the problem? Unlike West, our population is very large. You also agree, India is a price sensitive country. If I can get onion and potato, I discussed some time back, slightly cheaper. I mean, not me and you, by and large, we will not compromise to buy. This is not correct here. But what to do? We need affordable healthcare. For affordable healthcare, BARC in particular, DAE, we have made very impressive contributions, you can see from here. Nuclear waste, no waste is we should not say waste. Each waste has got wealth. I was talking about Nalco Dawanjodi plant, we discussed many things. We discussed about coal fly ash. These are the ways which have got unthinkable wealth. It is up to us how do we exploit this. So you can see here, we have separated radionuclides. I showed you from my previous slide. So for health applications, they are used for early diagnosis of cancer. Very early diagnosis. They are used for treatment. And what we do, we take a radioisotope, we complex with a chelator, we add a carrier for targeting. So like an arrow, it hits that cancer cell. And lot of work has been done. They are used in cardiology, oncology in a very big way, neurology, palliative. So these are the products. I show some of the photographs in this, and they are produced in Dhruva reactor. Some are produced in Apsara U reactor, as you can see here. And we also produce some reactors, in VCC Kolkata. VCC Kolkata, we produce accelerator-based radioisotopes, positron emitters, and so on. So where they are used, there is 64 copper, which is a positron emitter. Our doctors are using it in TMC, Tata Memorial Hospital, to diagnose prostate cancer. Glioblastoma is a brain tumor. So you can do early detection of cancer by these protocols. RU106 is a beta emitter, and RU106 plaques have been developed by BARC for treating ocular cancer, eye cancer. Many times even kids have eye cancer, small kids. This, a German company was selling them in 10 lakh rupees per plaque. 10 lakh rupees is not a small amount for many, many Indians. And here we are providing in rupees 50,000 because profit making is not the motto of DAE. DAE's motto is to serve to the society. And this is a remarkable contribution of Department of Atomic Energy, BARC in particular. Now, one slide on water security. I can go on talking, but I would like to have decent time for questions also. So, many times springs get dried up because they are not able to get replenished. So by isotope hydrology in Uttarakhand region, in Himachal region, in hilly region primarily, we have found the pathway of rainwater, how rainwater goes. And by this identification of pathway, we are able to charge these springs. This, in fact, in Uttarakhand, villagers say this is BARC water. This is a kind of importance our work has got. So this is one application in water security. I had discussed about energy security, food security, health security, water security. And now some applications for industry. What I am giving you only some examples, then I will refer a book to you published by me and Dr. Mohanty. You can download and you will know more about what I am talking in this lecture. So we talk about smart cities. India is undergoing rapid urbanization. Why not? Each villager has a right to shift to cities and make a better living for himself and his family. Problem comes that lot of municipal waste is generated. And what to do with that waste? So here we have developed cobalt-60 based municipal sewage sludge hygienization. This sludge has got lot of pathogens. The pathogen load is extremely high. So by cobalt-60 plant, Ahmedabad Municipal Corporation is able to convert this solid waste into manure. And this manure in this slide I have not added. Ahmedabad Municipal Corporation near Statue of Unity, they have converted a barren land into green land using this manure. So this is called as biosolid. And we look forward for more proposals from different parts of the country. Odisha, if we can get a proposal, I can assure you we will come forward and help to set up this kind of plant. Indore has been getting top ranking in Swachhta Abhiyan for last 70-80 years. Indore has one such plant. So you know the contribution towards urbanization in this country. Now some more applications. Sometimes industries have got these leaks in heat exchangers, and these micro leaks are so tiny that most conventional techniques are not able to pinpoint where is micro leak. These micro leaks can be determined very accurately by radioisotope technology, and then it can be plugged in. So lot of rupees, lot of exchange, the funds are saved for our industries in this process. And we have got buried pipelines carrying oil, carrying gas, and so on. They also develop leakage, and it causes lot of loss to the revenue. So for pinpointing the leakage in underground, see if it is overground, we can anyway do it easily. For underground pipes also, bromine 82 is a radioisotope which has been used to find out the location of leakages. And this contributes to economic growth as well. The loss of revenue is as good as generation of revenue. I would say that way. Now, DAE also is proud. I on behalf of DAE, I am proud to announce that we also participate in mega science projects. One is our own. This is MES Gamma Ray Telescope. MES telescope is in Ladakh, the Henley area of Ladakh. It is the largest telescope in Asia and second largest in northern hemisphere of the world, and 4.3 kilometers above sea level. This telescope is an international facility. It is used to study dark matter, dark energy. Any of the physics student who want to use this facility, you are most welcome. I will personally ensure that you get access to this facility. And we are part of several other projects. ITER, International Thermonuclear Experimental Reactor, France, we are a partner. CERN, we are a partner. Dr. Ajit Kumar Mohanty has done a lot of work in CERN, our chairman of Atomic Energy Commission. LIGO India is coming up at near Pune, Hingoli, in collaboration with Americans. Formulab also is a collaboration. These are the international collaborations, and in what way they help India. These kind of large collaborations are strengthening our heavy industries, because many components are now fabricated in India. So indirectly we contribute to the growth of industries also by joining these kind of international projects, very crucial. And there are other projects like green hydrogen, next generation research reactors, next generation proton accelerators, indigenous production of rare earth magnets. These are some of the other prime areas which we are working on. Now, last one example or two examples of one more security which is equally important. You will agree with me, national development and national security are two sides of same coin. You cannot have national development ignoring national security. And national security is important, but national development is also equally important. And as mentioned by Honorable Vice Chancellor, recently you saw Might of India. Let other people also listen. How we took so-and-so head on. Whole world is appreciating us. Whole world is appreciating our scientific prowess, technological prowess. More will not talk, just two examples. Pokhran 1 happened on 18th of May 1974. I was little less than 10 years. And I was exciting, jumping, without knowing that in 85 I'm going to join this department. That no one can predict here. Then came 11th May, second Pokhran. And that's why we celebrate, we are today together. In 1999, then Prime Minister Shri Atal Bihari Vajpayee declared that now onward, 11th May will be celebrated as National Technology Day. Young students, what is the day for National Space Day? I am fond of asking questions also. Who will answer? Loud? Susangani, you have something to say? Okay. When our Chandrayaan 3 landed, you should not forget. 23rd September. Very good. Date? 23rd. So it is declared as National Space Day. These are the days we should celebrate as proud citizens. We should not say it is done by ISRO, it is done by this, done by this, done by Indians. This is the underlying message to all of you. Pokhran 2, INS Arihant. India has become 6th country to develop nuclear powered submarine. And you see here in August 23, this reactor attained criticality. It completed Daedalus patrol like this, east to west. You can see in November 2018, and here is Prime Minister of India visiting INS Arihant. So this is the contribution towards national security. National development, national security, net zero, we all are in a position to contribute wherever we are. Not that we have to be in premier institutions. Wherever we are, we can contribute and we should contribute. Now, what is the future of nuclear power? This question is often asked to me. So right from my growing up years to till recent years, we have been reading that oil-rich countries may not need any source of energy. They have so much oil. But you see here, Barakah Atomic Power Plant, UAE, they have got 4 power plants, each capacity 1400 megawatt, and they produce 25% of energy requirement of UAE now. This is the future of nuclear. When an oil-rich nation is thinking of nuclear, you can imagine our situation. We have to go only, and leadership has been very supportive of atomic energy program, as you can see from this slide. Now, as I mentioned, that some books I will refer to you if you want to know more. All these 3 books are available. They are downloadable. Go to Google, punch this title, and it will take you the link. It will take you the SIRD link of BARC. This is non-power applications of nuclear technologies, published by me and Professor Ajit Kumar Mohanty sir. 75 you see here. And this is atomic energy in India, achievements is independence. This is also by myself and Professor P.R. Vasu Rao, former Vice Chancellor, HBNI. 75 you can see here also. 75 years of chemistry in Indian Atomic Energy Program, rich legacy and way forward by me and Dr. P.A. Hassan. 75 is common in all 3. So all these 3 books were either published or the idea was conceived during Azadi Ka Amrit Mahotsav. That is 75 years of India's independence in 2022. That's why they have got some tricolor type of, you can see the tricolor is seen somewhere or the other in these 3 books. I will recommend they are popular books. They are not too technical. I promise myself that these books will not be too technical. So they are more of story type. And these books I will recommend to everyone who is keen to know more about the program of atomic energy by our department. With this, let me thank once again Professor Acharya sir and Professor Nanda sir, Professor Parida, and all those who are sitting here. And last but not the least, the young students for maintaining pin drop silence. Thank you very much. And as I mentioned, that I will take questions. So someone should start a dialogue. Maybe from seniors. Can I have a glass of this cup of one water also? Please, please. Cohort 60. Yes. Waste. Yeah. So because sewage has got a lot of pathogens. So these pathogens are killed by cobalt 60. And after, bringing it down to the acceptable level, we can add sodium, potassium, phosphorus, NPK to make it a manure. So cobalt 60 job is just to remotely irradiate. So these boxes, there's a conveyor belt, and boxes come, pot boxes, and they pass through the source of cobalt 60, and it moves. That's how it goes. Yes. Yes, yes. Mumbai has got two food radiators. In fact, three. One is at BRC itself. 1967 it was commissioned. It is somewhat small scale, but this is the first one. Then we have got in Vashi, that belongs to BRIT. And there is a place, Lasalgaon, near Nashik. So there also we have got. And now recently, along with this food radiator, we commissioned a cold storage also. Now there are many things in pipeline, and private sector has come forward in a reasonably good way. Now maybe 25 plus or 28 belong to private sector. In fact, I met some very senior policymakers from Odisha. They wanted to set up here also. Somehow we have to revive this. Greenhouse gases. CO2 is one. Then we have got carbon dioxide is one, of course. We have got N2O, methane. Methane greenhouse gas potential is 24 times that of carbon dioxide. But we are worried about CO2 because CO2 has got infinite life. Methane, N2O, chlorofluorohydrocarbons, they all degrade. So it is CO2. Greenhouse gas potential of CO2 is the least, but its life is infinite. Yes, Susan. So on lighter side, I asked a lot of questions during your Viva. Now it is your time. Yes. If you can give mic to her, or you come forward.
For me to ask you question.
No, you can ask any time, please.
Sir, is nuclear waste is still radiative active? It still contains isotopes or what, sir?
Yes. This is a good question. After nuclear waste comes from a reactor, spent fuel, it has got three types of radioisotopes. One is somewhat short-lived. They decay.
Yes.
If half-life is 1 year, in 10 years you can say it is at par with normal environment. Then medium half-life, then long half-life. Very long half-life means they can be millions of years or so. So they continue to stay. So for that we have got protocol of separation and then immobilization. So I can assure you we have got unblemished record of never ever any radioactive material ingressing into normal life. Never ever. Unblemished record. I am proud to say that.
Thank you, sir. Thank you, sir.
I have a question on the power sector.
Please.
So what I understood from this presentation, you are producing more or less 9 gigawatt right now.
9 gigawatt.
And you are moving towards 23 gigawatt.
Yeah, correct.
So if you look at the power, the volume is right now 450 gigawatt, out of which almost 280, 290 or close to 300 maybe from this.
Coal and all.
Right. And if you look at 2030, they plan 300 gigawatt from renewable, which will fit 50% of the total. So our total power installed capacity may go up to 600 gigawatt. So by 2030, what could be the footprint of nuclear?
Yes, this is such a good question. So the government of India has been a mandate to install 100 gigawatt by 2047. Out of 100 gigawatt, DI is likely to go for 50-55, and 45 gigawatt will come from other players. So 100 gigawatt is the mandate given to us.
Right, because if you look at 50% of the power is now going to be from renewable, which is 30 to 40% is inverters.
Yes, yes.
So now the grid is going to be from
In a
inertia
very big
to
way, in a very big
inertia less. So
Yeah,
that is
yeah.
the reason government, the national planning is to introduce the nuclear, which will
Yes,
replace
yes.
the thermal.
As we discussed at length during lunch also.
Right. So
Now many things are in pipeline. For example, captive power plants we were discussing.
right.
Now most of them use coal. So now high time that we go for nuclear. And they are almost off grid. They are existing only to take care of this large size, plant, be it aluminum plant, be it steel plant, or other large plant, ammonia, etc. These captive power plants and NTPC also has signed a JV, joint venture with NPCIL. So now nuclear is really going a very rapid change.
Right.
Compared
100
to the time-
gigawatt, 100 gigawatt, I think, is a very progressive plan.
Very, very impressive number. And we have to work very hard for that.
Thank you.
Please, please.
So the power plant it is a uranium engine, right?
Can you repeat?
In case of the nuclear power,
Mm-hmm.
the radioactive material is uranium.
Mm-hmm.
But in India, we have the largest source is the thorium. So there must be some work going on to harvest energy from the thorium. So what is the expected timeline to harvest energy from thorium?
Mm-hmm. This question, wherever I go, comes to me and should come to me. As simple as that. So, as I mentioned in my first few slides, thorium is not a fissile material.
Yeah.
Let us admit, let me explain you that there are only 3 fissile isotopes. One is U-235, Pu-239, and U-233. 90Th232 is not a fissile element. You can't make it to undergo fission by thermal neutrons and get electricity like U-235 and Pu-239. So first and foremost, please, I would explain to you that thorium as such cannot be used to make reactors because it can't be fissioned by thermal neutrons. What is to be done? Convert thorium into fissile material. So thorium is a fertile element, so it can become U-233. 90Th232 N-gamma reaction, 90Th233, one beta emission, one more beta emission, and you get 92. From 90Th232, we get 92 U-233, and that is the fissile material which comes from thorium. So thorium is going to be used to make nuclear reactors by this route, by converting it from fertile to fissile. But it is at R&D stage.
So
It is at R&D stage not only in India, all over.
And another question, you are saying that it is in pipeline, they are thinking about it. But we are listening the Jaitapur power project, then there are Kobada power project. In case of the Andhra, the talk is going on since 2 decades. And it seems that nothing is going on. What is the operation? How long it takes to make a power plant?
Jaitapur may see light of the day soon. Sometimes there are many things. Perception also is very important. The other questions I have to handle, publicly. Perception sometimes goes, public perception also sometimes, plays a role here. More we discussed during cup of tea. So it is not that we are at fault here. Department is not at fault here. There are many things at times here, which, projects get delayed for many reasons here, which policymakers have no control. Department has no control. There are other regions. There is one more. See, this is only one half. Other half is public. So there are many things which I can discuss with you one-to-one. But we are very keen, and all these projects will see now light of the day in coming decade or so. Jaitapur is going to be revived.
Okay, thank you.
If questions from a student don't come, I'll be unhappy. You can ask me any question, by the way, beyond my talk as well. Yes, I see one hand. So please give mic to the young lady.
Thank you, sir. Sir,
You can come forward in the meantime. Please, please.
sir, what are the most precautions used in BRC to prevent accident in the case of nuclear instrumentation?
You have asked such a good question. Not only BRC, all our nuclear power plants are so safe. Till date, we don't have any, can I say, reportable accident of that kind here. See, our reactors are working for 52 times. Our nuclear reactors have worked at a stretch for 1 year. Not once or twice, 52 times. One of our reactor worked at Kaiga for 962 days at a stretch. This is second longest in the world. All this comes because of exceptional safety protocols. Not to worry, I will say that.
Okay, sir,
We have
thank you.
different types of, we have 2-level, 3-level safety protocols at disposal. One question from there also. Yes.
Good evening, sir. Sir, my question is, you told about the nuclear reactor, and in nuclear reactor, the uranium is also used. So there is a place in Jharkhand called Jaduguda, where is the biggest nuclear mine is present.
Yes.
And that's the, I would say that's not an opportunity for the India, because there the ground level is very critical for the people living there. They're also suffering for many diseases which will affect, which is also affecting their younger generations. The babies are also dying. They are not born even inside the womb. So what's your opinion about this?
Good question. So we have a lab in Kerala, Kolam. Name, let me recall. Kolam, not Kolam, I think. For last 50 years, data is being generated for the population living close to beach sand containing sea coast, where we have got natural background very high. So each baby born in this area is, on day one itself, everything is noted. As the child grows, everything is noted. And then there are control experiments. It means population living faraway places where there are no such things here. And I can tell you, this is very well documented that there is no additional prevalence of any disease. So please don't get carried over by lot of media propaganda also. I will use this word here. And please remember, when country does well, when individuals do well, it is true for individuals also, many negative things are talked about here. Learn to ignore. There are many vested interests who will say this is happening, that is happening. Not to trust. Come to BRC. I invite all of you and we'll arrange your visit. You yourself will see, since the living, you yourself will see how safely we operate our facilities. Don't go for media propaganda. Don't get carried over.
Okay, sir, can I ask one more thing?
Of course, why not?
Sir, in this about, so there is an article in Times of Hindu and the Telegraph India. Is they telling lie?
No, I'm not telling that they are telling lie. But please remember that one question I'm asking to them through this forum: how long they have done the research? For 1 week, 1 month, 1 year? I am contesting them with 40 years plus research. Here is the answer.
Sir, if there is anything happening, so is it wise to ignore these things?
Be careful. As simple as that. Be slightly extra careful. But don't get carried over. There are many things happen. Actually, I am ready to participate in debate with all these people who are publishing, and I will prove them wrong.
Thank you, sir.
Dr. Tyagi, this is A.K. Tripathi speaking from video mode. Am I audible? Hello?
Hello.
Is it audible?
Thank you,
Tripathi
Dr. A.K. Tyagi. I hope all of you must be hearing a very important what I can say, experienced and very focused, very targeted, and purpose of the time speech by or deliberation by Dr. Tyagi. It was all connected with the human perception, human value, and concern for society, concern for environment, and also SDG goals as per the UN commitment. I'm not going into that. Now it is the time to felicitate Dr. A.K. Tyagi. I cordially invite Professor Damodar Acharya, Professor P.K. Nanda, Honorable Vice Chancellor, Professor Kulamani Pareda, Professor B.K. Mishra, Professor Subhranshu Ranjan Samantrai, Professor U.C. Mohanty, Professor Ganpati Panda on stage to have a group photo, and along with will felicitate Dr. A.K. Tyagi.
ସେ କ୍ୟାମେରାକୁ ବା କହିଲେ କଣ ଲାଇଭ ଷ୍ଟ୍ରିମିଂ ନା ନା ସେ କଣ କହୁଛନ୍ତି ଯେ ଷ୍ଟ୍ରିମ୍ ଦବା ପାଇଁ ତ ସେଇଟା ଦବା କ୍ୟାମେରା ପାଇଁ ସେଟା କଣ ହବ କ୍ୟାମେରା
Dr. Debajyoti Das, Dean SPS, and Professor Renu Sharma, please come.
କାହା କଥା ମୁଁ ମାନେ ମୁଁ ଖାଲି ସିଏ ପୁରା ଅଫିସରେ ବସୁଛି ଚ୍ୟାନେଲର ହେଡ୍ ଅଛି ଯେ ମାନେ ଇଏ କଣ୍ଟ୍ରୋଲ କରିଛି ଏଇ ଲୋକଟା ଏଇ ଲୋକ ଏଇ ସଫଳ ସିଏ ମାନେ କ୍ୟାମେରା ଅପରେଟର ସେମାନେ ବୁଝୁଛନ୍ତି ଭଏସ ଏଇ ଦେଖ ଏଇ କ୍ୟାମେରା ଏଇ ଆମେ ଏଇଟାକୁ ଅନ୍ କରିଦେଲ ଆମେ ଏଇ କ୍ୟାମେରାଟାକୁ ଅଫ୍ କରିଦେଉଛୁ ଏଇଟା ମୁଁ ବି ଖାଲି ଅନ୍ କରିଛି କାହିଁକି ମୋ କ୍ୟାମେରାଟା ଯାଉଛି ତାହେଲେ ମୁଁ ତାକୁ
Now, Professor, please, 1 minute, please. Having patience is a responsibility. Maintain that. Few minutes more. Otherwise, staying for 1.5 hours will be waste. And you had a speech not to waste. That is what a part of sustainability. So now it is the time to felicitate Dr. A.K. Tyagi by Professor Damodar Acharya. Please come. And this felicitation is from SO University side. Let's have a big round of applause. Now, on behalf of INE Bhubaneswar chapter, Professor Subhranshu Ranjan Samantrai will felicitate Dr. A.K. Tyagi. Oh, sorry. Professor Damodar Acharya will also felicitate on behalf of INE along with Professor Subhranshu Ranjan Samantrai. Like every function, at last you know what happens, the vote of thanks. Now it will be by Professor Renu Sharma. Just have patience for a few minutes, please. Only it's more.
Honorable Chairman, INE Bhubaneswar Chapter, Professor Damodar Acharya Sir, esteemed distinguished speaker, Professor A.K. Tyagi Sir, Honorable Vice Chancellor, Shiksha Anusandhan, DMTB University, Professor P.K. Nanda Sir, Esteemed Professor S.R. Samantrai, sir, Chair IEEE Bhubaneswar Section, Professor Kulmani Parida, sir, Professor Varda Mishra, sir, Professor Ganapati Panda, Professor Jyoti Ranjan Dar, Dean Student Welfare, Sud University, Deans, directors, heads, and my dear students. It's indeed a great privilege and honor for me to deliver the vote of thanks on this spontaneous occasion of National Technology Day 2025, where we have gathered to celebrate the spirit of scientific innovation and technological excellence that continues to drive India forward. On behalf of INA Bhubaneswar chapter and its team, co-organizer, Shiksha Anusandhan deemed to be University, IIT Bhubaneswar, NISER Bhubaneswar, CSI RMMT Bhubaneswar, ICT IOC Bhubaneswar chapter, and IEEE Bhubaneswar section, I extend my heartfelt gratitude to all who have made this event a grand success. We especially thankful to Professor A.K. Tyagi sir, Dean and Senior Professor Homi Bhabha National Institute, Mumbai, for delivering an opening distinguished lecture on extremely relevant topic, sustainable development, role of nuclear science and technology. Sir, your lecture today illuminated the critical role that the nuclear technology plays not just in energy security, but also achieving long-term sustainability goals of our nation, such as food security, water security, health sector securities, and many more. Your insight has left us deeply inspired, sir, and we are really intellectually inspired and enriched. My heartfelt thanks goes to Professor Damodar Acharya, sir, for organizing this distinguished lecture series. My sincere thanks goes to all the invited speakers of this distinguished lecture series that shall be organized in subsequent days. Your all participation adds immense values and meaning to the celebration, creating a platform for knowledge and innovation coverage. My sincere thanks to Honorable Vice Chancellor Professor P.K. Nanda sir for enlightening us with a welcoming speech. I also thank Professor Samant Rai sir for shedding light on INA. I also thank Professor Kulmani Parda for beautifully introducing the esteemed speaker of this event, and special thanks to Professor Jyoti Ranjan Das sir, who is a student, a Dean Student Welfare of our university, for phenomenally executing this program. Not only that, my sincere thanks to all the invited speakers, distinguished lecturers, and head and directors of all the collaborating institutes for unwavering support and partnership to organize this event. Your collective vision and coordination have made this program a great success. That is not the least, I would like to thank each one of you present over here, faculty members, students, and invited guests for the enthusiastic participation in question and answer and the response by our eminent speaker of the event. Your presence truly reflects the spirit of National Technology Day, a day to remember our scientific achievements, honor of our innovators, and ignite young minds like you for the future. Let us carry forward the discussion and inspiration of today's shared goals of sustainable and technological empowered India. Thank you, Jai Hind.
Thank you, Professor Sharma. It will be a great mistake in our part if we do not thank the person who is not here, who never comes, who never attends, only appreciates and only visualizes how the organization will go further. Professor Manoj Ranjan Naik, the founder of SY deemed to be university, in absentia we are proposing the vote of thanks. I request everyone present here to rise for the national anthem. Silence, please.
हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Finally, it is over. Thank you all.